I want to take the starting point in this model from bimbone.dk, Revit case study, at page 181. Our client is quite happy about the design for now, but we will make some minor changes to the design before going into the next phase. I often see beginners in Revit make solutions at the roof like this one, thicknesses of more than 500 millimeters. Typically, it's not the design we have in focus, but more an expression of not forgetting the large amount of insulation we need to have in the construction. In the following example, I'll show you how you can benefit of dividing one roof into two separate roofs by having a roof covering and a roof construction. If we take a closer look at this example from the real world, you'll see in Revit that I have divided this roof into two. So if I open this new project, you'll see that I have separated one roof into two, and that will give us the expression as it was built in the real world. So we have some walls and we have a roof covering and we have the roof construction underneath. Another typical roof construction in Denmark is having the roof to end like this. And the way we can solve that in Revit is actually the same way. So we have a roof covering, we have the walls attached underneath. And if we take a closer look at the roof covering, you'll see that the boundary is not aligned to the exterior side of the wall, but we have a distance of 20 millimeters. And to create the roof construction underneath is just taking a copy of the roof covering and then change the type to construction and then edit the footprint. And move the boundary lines into the walls, and we'll fix that in the next phase. If this is the design that our client likes, then we can fix that in the next phase. Again, if we take a look at some inspiration photos, this is maybe more the expression that I would like to have in our own model. So I go back to my main model. So what we would like to change is this 0.5 meter thick roof, and we will change that into something slimmer. So first of all, let's have a look at what we actually very easy can do for having a slimmer construction. If we take a look at the fascia depth of this one, if it's only set by plumb cut, we'll have this this huge edge all around. But if we change this to 2-cut plumb, you'll have the expression of a slimmer roof at the front of the house, but we cannot change at the gable ends. So we need to change this into another type. So we're in the outline proposal phase, and we're working with generic components. So we change this into something 150 millimeter thick. Not very sure about the thickness for now, but we'll find out later when we begin to sketch the different components. We'll find out the specific thickness. This is more the expression that I would like to have. So if we move to a section, I have my work in progress section here that I can move around in my model. If we take a closer look at that, we can see that our roof is made as a profile. And that makes it a bit hard for us to to do the same as we did before, because we don't want to have insulation in the areas where we have the covered terraces and our carport. So we need to create the roof construction from scratch using roof by footprint. So I start unchecking define slope and set the offset to 240 millimeter approximately in the middle of the wall. And since we unchecked define slope when we created it, we need to select the different roof sides and say that we need to have a slope, and the slope should be very specific according to the roof covering. As you see, I wasn't aware of that I created the roof on the wrong base level, so I changed that. And it's still too high, so I move it down. But then you see that this north side is not correct, so we need to move that down 551 millimeter. So I open the ground floor plan again and say minus 551 millimeter offset. Then it will be correct. And so if we move our work in progress section, we'll see that we need to change the offset from roof on this side as well. To make the model correct and consistent, we need to attach the inner walls to the underside of our roof construction. So I select one of the inner walls. Now I know that all the walls interior are the same, so I select one wall, select all instances in entire project, but I don't want to have the wall in the kitchen, so I hold my shift key to deselect those two walls, and then I attach top base to the underside of our roof construction. Maybe this is not the best angle to select the roof construction, but I managed to do that now. Finally, here in the outline proposal phase, we'll have a look at some of the output material that we have to deliver from this phase. Generally speaking, it's about doing as little model work as possible before we have the client's approval. So that means low detailing and high scale. So save the file, and that will be it from the outline proposal phase. Going into the scheme design, we start by opening the outline proposal phase model and save this as a scheme design model. In this phase, we begin to have an idea on the different building parts in the project. For example, the exterior walls that we have here. I start by changing these walls to a more specific building component. We'll have bricks, exterior, insulation, and then a lightweight concrete wall inside. When we look at this floor plan as we see here, we would like in the output that the scale is not 1:100 but 1:50. So we change that to have an idea on the expression of our final output. We change the detail level to fine, and we change the fill pattern of our soft insulation into a fill pattern that is according to the Danish national standard. Notice that if you have layers in your construction thinner than 25 millimeters, then we are not showing them according to decon in this phase. So let's apply a cut pattern, this bibs insulation soft, and I would like to tone it down a bit so it's a light gray color instead of black. So now we know that the construction of our external walls is made out of brick, and we know the sizes of those walls. We need to fit this into modules according to brick measurements. So a way to do that is to add grid to our model and lock the grids and our walls together, and then adjust our building according to the brick measurements. So I start applying grids to my external walls all the way around. And notice that I have an offset value of 6 millimeters from the inner side to my modular grid. So now I have adjusted all the grid lines so that it's nice. I will now lock together the grid and the wall by applying a dimension, and then I lock the two together. Remember, you can use tab if you cannot select the line that you want to select. So having applied all dimensions to grids and walls, I start adjusting my my model. So as you can see, if I apply a dimension between the two grid lines, it's not a brick measurement. It must be 1140. So I select grid line number 3 after I have pinned this wall. I select grid line number 3, select the dimension and change this to 1140 to adjust this just a little bit. So if we check this part of the brick, it's a brick measurement now, it's a pillar. So just a short time ago, we changed all generic exterior walls to this 468 millimeter brick and lightweight concrete. But since we have some garden walls that, well, first of all, it's not necessary to have insulation in them, and we need to have bricks on both sides of those walls. We need to change some of the wall into a different type. So instead of lightweight concrete and bad insulation, we change that. So we skip insulation in these walls by replacing them with just air. And we need to change one of the sides. I forgot that. to brick as well. So if we see our ground floor plan, we'll see that it contains no insulation now, but still it has this lightweight concrete, so we change that into masonry or brick common. And if we want to have the correct graphical expression, we can show that the brick work will wrap around the ends. So I set the default wrapping to exterior at ends, and then it looks more correct. And since the model came from our outline proposal phase, where we modeled as fast and easy as we could, you'll see that since we modeled the walls with openings using edit profile, we have to split those walls so that we can divide this into the correct building parts. So check out your model. We'll have, in this case, we'll have the issue here, over here, and where we have this this open terrace. So we need to fix that. But let's move on with another issue that we have to deal with. Where we have windows and openings, we need to adjust this according to brick measurements as well. So if we have a window and we have an opening, we need to change that into a brick opening size, which is 732. And when we have that opening size, we can now move the window a bit, and then we have the correct pillar size. So for now we have only changed our external wall. So we need to change some of the other generic components or building parts that we have in our model. For example, the foundation. So I select the foundation and select all instances in entire project. That will make it very easy for me to change it to another type. So I'll take this stacked wall that we have, foundation concrete at the bottom, and then a lightweight concrete block on top of that. And it must be aligned to the inner side of my external wall. If you prefer to lock them together, you can do that. Another important building component is, of course, the roof construction, as we changed in the outline proposal. So now we know a bit more about the construction. So we changed this into a roof construction. Maybe 580 millimeter is a bit too much. So we change, or we duplicate this and create another type. 380 millimeter might do it in this case. So we change this. And again, we move this up a bit, and maybe that will give us another fine adjustment, as you can see in the right side. Just a small note here. Remember that we have moved our external facade, so in accordance to what the original idea was with the roof, maybe you have to change the roof first of all, but we're not doing that now. What we need to do is to adjust the boundary of our roof so that it is at the back side of our inner wall. That will make our model very consistent, and that will give us, for example, the correct amount of insulation and so on. Again, there's a small adjustment that we need to do here now. Now we have updated our model, going from a generic model and into a very specific building part model. And we need to go a step further. So doing a visual check here, we'll see that we have some challenges somewhere, and we need to solve them somehow. I have added, for example, a ceiling because we need to have a ceiling over the carport and the covered terraces. So now I think we have a very consistent model, and we're ready to go into the next phase. The next phase will be that we want to be very specific on our constructions. So as you can see here, I have added 3 more sections. So all in all, we have 5 sections in our building, and they should hopefully overlook all the challenges that we have in our project and the challenges that we need to solve before we can move on. What I can do with the section, for example, if it's not supposed to be straight, I can split it, because I would like to see what happened over the covered terrace that we have. So now I have some sections, and on those sections I would like to take out some callouts so I can sketch on. So under View and Callout, I'll create a detail view. So I'll point out all the specific areas where I would like to go deeper into the constructions, where I would like to sketch. As you can see here, I have made now 15 callouts, and I would like to print them into paper, because I would like to sketch by hand afterwards. So I apply a view template in a scale 1 to 5. When I apply this to all of them, I can change settings, not only to 1, by all of them at once. I create new sheets, an A3 sheet, and I will then apply all my details to this or to the sheets, and prepare them and make them ready for print. Having done that, I rename my details in accordance to the standards, and then I use Design Review to export all my details and all my sections. First of all, to see if it's correct. Do we have something outside our title block, or is everything fine? It seems that they're ready to print, so I'll print all my sections and all my details. I'll print them into paper, and then I'm ready to sketch. So done with the sketching, I'll return to my Revit model and update my model in accordance to my sketches. So first of all, I'll select my roof covering and change the construction so that it will have my correct thicknesses of the different layers. I'll continue updating my roof construction, adding the correct thicknesses of the different layers. And the last one, I just rename my external wall because the construction, the layers are correct. One of the advantages working in a BIM model is that we can change the reference planes in the different levels. To fine-tune our model so that it fits into the brick measurements, not only on the ground floor, but also in the sections, we can use detail items and repeating detail items to find out the correct heights of, for example, our roof. So when we have a detail component, a detail item in our model, we can change that into a repeating detail item, making bricks every 66.6 millimeter, one brick, one joint, so that we can determine the correct place for our roof, optimizing the building in that way. At the moment, we don't know whether the lightweight concrete should be blocks or full prefabricated elements. So if we optimize our model that this inner wall should fit into steps per 200 millimeter, we can add this detail item and convert it into a repeating detail component. In one of the next videos, I'll show you how to create your own detail item so you can create your own concrete blocks if you would like to do that. But first of all, I place this repeating detail item to find out a good spot for placing our roof. But of course, it's something to do with the room height. So let's check if we have enough room height. I prefer to lower the roof a bit. So to find out the correct height of our inner wall, I will, in the then edu content, I will find a detail component on the wood. We have dimension lumber. Seems there is a bug in that one, but it seems that this is a 45 by 95 wall plate. So now I have the precise height of my roof, or where I would like to place my battens. So I can lower the whole construction 114 millimeters. So instead of 2600, it will be 2486. So this is the correct height of my roof, and I can lower the bricks. So actually this or those detail items or detail components, they will just be a guide for me for now to find the correct spot for our roof. So looking at our 3D model, we'll see that what we need to do now is to improve the components of the roof. So we'll start by adding gutters to the roof. I can see I forgot to change this one to the correct type. So I'll continue adding gutters. Another thing I would like to add is fascia. As you can see, we have a predefined 25 by 250. That was, according to our sketch, it's a bit too big. So under my family, I'll find the flat fascia here and create a duplicate, change the dimensions, and in type properties, I'll change the profile to this one. I can change or modify the metering at the ends, and I can apply the same fascia along the facade. It's not only for the gables. I can select every edge of my roof and apply a specific fascia. Finally, in this section, I will also look at the output of this scheme design phase. So don't be confused that, I have gone back to an earlier model, so you see that my drawing number is set back to what they were in the outline proposal phase. So don't be confused about that. So I'll change the title block to an A1. I will apply view templates. Then you can reuse the settings that we are doing now. You can reuse that later on. So I'll set the view scale to 1 to 50, detail level into fine. Even though that the green reference planes are not visible in a print, I'd like to remove them from here. So I'll hide the reference planes. I will hide plan regions, elevations, and in the model category, I don't want to see planting. Then I would like to hide all my WIP sections. So all the sections starting with a W, you'll see I have a filter here concerning all sections. It will apply this rule every time it meets a view name beginning with a W. It should do something. So I add this filter and say it should not be visible. So when I apply this, all my work in progress sections should be hidden on this floor plan. So then I can adjust or split the segments of my sections. I don't want to see them inside. That is also an option that you have if you don't want to see the grid lines going through the building. Some find this very annoying, so you can remove that. And then, of course, I will add some dimensions to the floor plan. Not completed, but this is some kind how I would like to see this. So I have done this already once, but let me apply the correct sheet number. And let us take a look at sections in a scheme design phase. So if I open my section AA, I can see there is already a view template applied. So I open the view template and make some changes that I would like to see. For example, I will have tone, grids and levels. I will hide reference planes. I will split sections, stuff like that, as well as I did on the ground floor. But more important is the connections that we have between roofs and walls, as we see on this detail. Right now we have double geometry on top of each other, so if we use the join command, we can join the roof and the wall, and by using cut profile we can decide what layer should be in front of others. So for example, here we have found out before that this is where my inner wall should end, and here I would like the insulation to continue to the back side of the inner wall, so I can apply this cut profile like this. Voila, you can see now I have updated all my sheets with the correct drawing names and numbers. And I would like to finish this phase by looking at spot elevations. As you can see that the elevation of this project is set to 47 meters above sea level. So if I add a spot elevation, a shared one, it will give me the correct elevation to my project. If you would like to add descriptions of your building components, you can use Keynotes in Revit. If you have your building component journal where you have all your construction described, you can connect that to your Revit model. So now you can tag the different constructions having the different numbers, or the constructions, or you can have both. If the descriptions of the different building components, they change over time, you simply update your Excel spreadsheet and update the text file, and then reload into Revit and the text will be updated. If you would like to see more on that, I can refer to my video concerning Keynotes. The Keynotes and their tags can be used also on the ground floor to tag the different building components, so you can identify the different construction from each other. You can create a legend so that you can see both the identification number and the description of the different constructions. So if I apply this Keynote legend, we'll see all the keynotes in this Keynote, and I can then filter out everything but my wall construction that I have on my ground floor plan. I can create a legend if I visually would like to have the wall, or if I have different types of walls in my project. I can then add this on top of this so that it's very visually what is in my project. So we come to some final issues. I have renamed the grids starting from 1 to 5, 6, and the horizontal starting with A at the bottom and then ABC. I have added downpipes to the facades so that we can see them both on sections and on facades, on perspectives. And in the end, you can see I have made some minor changes to the view templates to have the right expression, and that's about it. Remember to save this in the right name and not as I have done, as you can see. And I'll be back in my next video concerning detail design.